A boost converter is a type of DC-DC converter that increases the input voltage to a higher output voltage level. It is one of the most commonly studied and implemented converters in power electronics, and you will often find its circuit diagram in textbooks. The basic boost converter circuit consists of four main components: the inductor, the capacitor, the diode, and the switch. The switch is usually implemented using a MOSFET, an IGBT, or sometimes even a BJT depending on the application. The operation of the boost converter can be explained in two modes, depending on whether the switch is turned on or turned off. When the switch is turned on, current flows through the inductor and the inductor stores energy in its magnetic field. During this time, the diode is reverse biased and does not conduct. The load current is supplied entirely by the capacitor. When the switch is turned off, the inductor releases the energy that it stored. This energy adds to the input supply voltage and forces the diode to conduct. As a result, the output voltage becomes higher than the input voltage. In this mode, the inductor supplies power not only to the load, but also recharges the capacitor, which helps maintain the output voltage at a stable level. By continuously switching between these two modes using pulse width modulation, the boost converter is able to step up the input voltage to the desired higher output voltage level. These are the design formulas. The output voltage can be changed by changing the duty ratio. Inductor decides the peak-to-peak ripple current, and capacitor controls the output voltage ripple. Let's take a design example. Consider the input voltage is 12 volts, output voltage is 18 volts. Other design requirements are: output voltage ripple is equal to 1 volt, inductor ripple current is 0.45 ampere, which is 25% of load current. The switching frequency is selected as 50 kHz, which is well above the audible range. It is important to keep the switching frequency higher than the audible range. Otherwise, the converter would generate an irritating high-pitched noise due to the vibrations in the inductor and other components. Since the output voltage is 18 volts and the load is purely resistive, we can calculate the load current using Ohm's law. Dividing the output voltage by the resistance gives a load current of about 1.8 amperes. Now, using the duty ratio formula of a boost converter, we can calculate the required duty ratio. For this case, it comes out to be 33%. Next, we apply the design formulas for the inductor and the capacitor. By substituting the given specifications into these formulas, we can determine suitable values of the inductor and capacitor for our design. Once the component values are calculated, the next step is to simulate the circuit in MATLAB Simulink. Create a new model. From the top menu, click on Library. This will open the Simulink library browser. In the library, go to Simscape, then open Electrical. From there, select Specialized Power Systems, and then go to Fundamental Blocks. Inside this section, open Electrical Sources and drag a DC battery into your project workspace. This will act as our 12-volt input supply. In the same way, drag and place a ground block, and also select an RLC block. Once these blocks are placed, rearrange them to form the basic circuit layout. Double-click each block to edit its parameters and enter the values we calculated in our design example. Place our IGBT switch. Connect the components to make circuit. Now, place an ammeter and a voltmeter in the circuit to monitor the current and voltage. Add a scope to observe the waveforms, and adjust the scope settings as you prefer for a clear display. Also, insert the duty cycle control for the switching signal. When you run the simulation, you will see that the output voltage settles around 18 volts, and the load current is about 1.8 amperes, just as expected. By changing the duty ratio, you will observe different output voltages. In fact, as you increase the duty ratio, the output voltage also increases, which perfectly demonstrates the principle of a boost converter. That's all for this tutorial. Thanks for watching, and don't forget to like this video and subscribe to my channel for more electronics and power electronics content.